Welcome back. One thing you might have thought about would be that if you were to take either the equation of an ellipse or the equation of a circle and expand out those perfect squares, you would have some x squared terms, some x terms, some y squared terms, some y's, and maybe some constants. And any ellipse or any circle can be written in this form, where A happens to be something positive and B happens to be something positive. If A or B happen to be negative, this would actually be a different shape, not an ellipse, not a circle, but that's not something that's part of this course. So for us, we'd be looking at things where we have some sort of a y squared term and also some sort of an x squared term, and the coefficient for the x and the y squareds are both positive. Now, if the coefficients for the x squared and the y squareds were the same, if a and b were both equal to each other, then you would have something that is a circle. If you didn't have them equal to each other, if a and b were not equal, then what you would have would be the graph of an ellipse. Now, in either case, if you wanted to figure out what are the relevant features for that circle or that ellipse, you're going to need to do some completing the square to make that happen. Because, of course, you're going to want to take that x squared and x term and rewrite it as some sort of x plus a number or x minus a number squared, and you'll want to do the same thing with the y squared and y. And for both of those, we use completing the square to make that happen. So what we're going to do now is look at a couple of examples. We're going to have things written in this more general form, x squareds and y squareds and x's and y's and constants. We're going to rewrite it in standard form once we figured out whether it's the ellipse or the circle that we have. And then we'll figure out the relevant features and then graph from there. So for this, I'm going to start off with first noticing that the coefficient for the x squared and the y squared terms are not equal to each other. So that means that this is not the graph, or this will not be the graph of a circle. This will be the graph of an ellipse that we'll be creating. So these are not equal, which means that it is an ellipse. Okay, so that's our first thing that we'll need to do. We know that it's an ellipse, and so that tells us that we're going to need to get it into the form where we have x minus some sort of number squared over either a squared or b squared, y minus a number squared over either a squared or b squared equal to 1. This is the form that we're going to need to get it into. And so to do that, we're going to need to complete the square. And to make that happen, I'm going to first bring the x's together. And the y's, leave them with each other. And I'll move that 7 to the other side of the equation. Okay. So the first thing that I'm going to do, I'm going to complete the square for the x's. And to do that, first I'm going to divide everybody left side and right side by 2, because I want to have just x squared. I don't really want 2x squared. Okay, so for the first two terms that I have there, if I'm completing the square, I would look at the coefficient for x, which is positive 4. I would take positive 4 and cut it in half, and that would give me positive 2. And positive 2, when I square it, that would give me 4. So 4 is the amount that I would add to either side of my equation. So on the left side, I'll have x squared plus 4x plus 4. And on the right side, I would have 7 halves plus 4. And 7 halves plus 4 turns out to give me 15 halves. So that what I have here on the left side simplifies as x plus 2 whole thing squared. So I've completed one of the squares. And now I just need to do the same thing with the second part, which the y's. I have to complete that square. And I'm going to do kind of the same thing there as well. You'll see that I've got 2y squared. Here, I'm just going to add an extra page. There we go. I have 2y squared here in my my y terms, and I'd like it to just be y squared. So I'll divide everybody left side and right side by 2. So first term divided by 2, the y terms divided by 2, and then 15 halves. When I divide that by 2, that is 15 quarters. Okay, so now time to complete that square. We have y squared minus 1y. And if we're thinking about taking that -1, that coefficient for the y, multiplying it by a half, that would give us -1/2. And when we square -1/2, we get +1/4. So 1/4 is what I'm going to need to add on to either side of the equation. So that what I'll have in the middle, y squared minus y plus 1/4, that is the same thing as the perfect square y minus 1/2, all squared. And on the right, I have 15 quarters plus 1/4. That's 16 quarters, which is the same thing as 4. Okay, so we're almost finished. Remember that for this to be in standard form as an ellipse, this value on the right side would need to be a 1. So I'll divide everybody by 4, and that will make that happen. I'll say that dividing everybody by 4 will give me x plus 2 squared over 8. I'll have y minus 1/2 squared over 4, and then equal to 1. So we have our ellipse in standard form. That's kind of nice. That tells us also that we have our center for this ellipse being at -2, 1/2. And if you're thinking about the major axis, that would be, since the larger value for the denominator is under the term with the x's in it, the major axis is parallel to the x-axis. And a would be the square root of 8, which in simplest terms is 2 root of 2. And the minor axis is going to be parallel to the y-axis. And b should be the square root of 4, which is 2. So I'm just going to say a couple of things before I get into the graphing here. Remember, as I've said a bunch of times already, but I'll continue to keep saying, I really do want things to be expressed in exact values. So although you might look at your calculator and say 2 root of 2, oh, that's a little bit less than 3, that gives you an idea of roughly how many units to the left or to the right will be going from the center. But when I label things, I will not be labeling my coordinates with decimal values. I'll be labeling them in terms of those 2 root of 2's. So I'll start off with plotting my center, and then I'll work on my vertices and covertices after that. So starting with my center, we had the point which was -2, 1/2. So I'll label that there. All right, and as I said, for the major axis, which is parallel to the x-axis, the value for a was 2 root of 2, which is just a little bit less than 3. So we'll be going just a little bit less than 3 units to the right, which if you went 3 units to the right from that center, you'd be at 1, 1/2. But we're going just a little bit less than that, so we'll be a little bit less than 1, 1/2. And when I label that point, I'll label it as -2 plus 2 root of 2, comma a half. It's that value because we were at the center, which had x coordinate of -2, and then we went to the right by 2 root of 2. Similarly, when I plot my second vertex, I'll be going almost 3 units to the left, so I'll almost be at the x value of -5, not quite. And for that, my x coordinate would be -2 minus 2 root of 2, because I've started at -2 for my x coordinate, and I've gone 2 root of 2 units to the left. And then now in the y direction, for b, the value was 2, so from the center point, we'll be going 2 units up. And so if we take 1/2 and we add 2 to it, 1/2 plus 2, that's 2.5, or 5/2. And if we go 2 units below, that would bring us to -1.5, or same thing as -3/2. So the second y coordinate is -3/2. There we go. Now I'm just going to draw my ellipse as best as I can, trying to make it as smooth as I can. Relatively okay. And now the only thing left for me to do is just label my graph. So I have x plus 2 squared over 8 plus y minus a half squared over 4 equal to 1. There we go. So there's a nice well-labeled graph of that ellipse. So just to circle back so we can sort of see this again, we start with recognizing that since the coefficients for the x squared and the y squared terms are not equal, that it must be an ellipse, not a circle. And then we just complete the square twice, once for the x's, once for the y's, and once it's in standard form as an ellipse, then we can identify the center, we can identify A and B, and then from that we can create the graph of our ellipse. All right, let's do one more. So here I notice that the coefficients for the x squared term and the y squared terms are equal to each other, which means that this is a circle. So there we go. It's going to be a circle, which means we're going to need to get it into the form x minus the center coordinate squared plus y minus the center coordinate squared equals radius squared. That's eventually the plan for us. And also, we know that that we're going to need to complete the square twice then, just like before, once for the x's, once for the y's. So I'll start by first, just like before, bringing the x's together. And the y squareds together, and bringing that constant to the other side. And since I'm going to complete the square for the x's, I'm going to divide everybody by 3 so that I'll just have x squared. And then I can start completing my squares. And actually, here I can go a little bit faster because you'll see that I've got just x squared by itself. I've got just y squared by itself. So actually, I could, in one step, do both completings of squares. So for the x's, if we're thinking about what needs to be added to complete the square, we would take half of -2, which would be -1. And -1, when you square it, it's 1. So I would add 1 to both sides of the equation, and that would complete the square for the x's. For the y's, we'd look at the coefficient of the y term, +4, cut that in half, that's +2, and +2, when you square it, it's +4. So +4 needs to be added to both sides. And the first 3 terms, that's the nice perfect square of x minus 1, all squared. The second 3 terms, this would be the same thing as y plus 2, all squared. And on the right side, 3 plus 1 plus 4, that's equal to 8. So that means that our center is 1, negative 2, and our radius is square root of 8, which is 2 root of 2. Now, same thing is also going to be true here when I'm graphing this center, that when I label my coordinates for the point that's above, below, to the left, and to the right of the center, I'm going to be writing it as an exact value, so it'll be written involving 2 root of 2. I will, in my mind, think about how 2 root of 2 is close to 3, so that I know roughly where to put my points, but when it comes to the labeling, I'll be labeling them not with any sort of a decimal value, but I'll be labeling them with 2 root of 2's. So we'll start off with plotting our center, and then we'll plot our 4 points, and then we'll draw our circle. So our center is at the point 1, negative 2. There we go, and I'll label it. Also, as always, notice that my axes are already labeled, that I've got my tick marks labeled, that I've got my tick marks drawn on nicely on the X and the Y axis. If you're drawing by hand, that would be the first thing that you'd make sure that you've done. And that when we're plotting any of our points, remember that we'll be labeling those coordinates. So, as I said, the radius of 2 root of 2, that's almost 3. It's a little bit less than 3. So we'll be going a little bit less than 3 units above. So 3 units above would bring you to the point 1, 1, so we'll be a little bit less than it. And so what did we do? We started at the point 1, negative 2, and in the y direction we went up by 2 root of 2. So the coordinate for that point above should be 1, comma, negative 2 plus 2 root 2. And same thing is true if I'm going 2 root of 2, or almost 3 units below. The coordinates for that point would be 1, comma, negative 2 minus 2 root of 2. And then for the points to the right and to the left of the center, going almost 3 units to the right brings me to the point 1 plus 2 root of 2, comma, negative 2. So we started with an x coordinate of 1, and then we went 2 root of 2 units to the right. And then similarly, going almost 3 units to the left will almost bring us to an x coordinate of negative 2, not quite. And we'll label that as 1 minus 2 root of 2, comma, negative 2. And now I just need to draw my circle as best as I can. My circles always turn out on at least one point to look a little bit pointier than they probably should, but this is good enough. The whole point of this is not to try to do what a computer could do perfectly. Of course, we're drawing by hand, and so our graphs won't look perfect, but the goal is to have a well-labeled graph that would show all of the important features. In this case, the important features for a circle would be the center and the coordinates above, below, to the left, and to the right. Those would be things that somebody would want to know about if you were presenting them with the graph of a circle. Last thing to do, of course, is to label the equation of the graph. So I have x minus 1 squared plus y plus 2 squared equals to 8. And there we go. As always, axes labeled, tick marks labeled, points are labeled, the equation is labeled. So there we go. We've got a well-labeled graph of that circle.